Good day, grade 10s. Today we're going to talk about quadrilaterals. So, quadrilaterals, before we can get into quadrilaterals, I'm going to talk about the Orion constellation. So, in order to get a good glimpse of what a quadrilateral is, right? So, if you look at the definition of a quadrilateral, it says what? A quadrilateral is a closed shape consisting of 4 straight line segments. Now let's look at the picture, this picture of Orion constellation. If we look at this picture of Orion constellation, we see stars, we see Betelgeuse. This is Betelgeuse. And then we see Bellatrix. And then we see, I'm gonna only talk about this few, and also this one, Scythe. These are interesting stars, and then you can see other stars there, but I'm only gonna talk about these 4 as an introduction to the lesson. So if you look at these stars, right, if I connect their positions, I'm gonna form a 4-sided figure. Can you see? Now the 4-sided figure that I have formed, that's what we call a quadrilateral. So basically a quadrilateral, quad means 4. So a quadrilateral is a 4-sided figure. So that's what a quadrilateral is. A quadrilateral is a what? It is a 4-sided figure in 2-dimensional space, right? So, and also, now let me talk about these stars, these 4 stars that I have circled, right? Hopefully it might inspire some of you to pursue astrophysics in the future. So the first one is Betelgeuse, this is Betelgeuse, as you can see. Now Betelgeuse is a red supergiant forming the Orion's right shoulder. As you can see, it's on the right. As you can see, it's not on the right basically, but it forms the right shoulder of the Orion shape, right? And it is in a late stage of stellar evolution, having expanded after using up its core hydrogen. So, and according to research and observations from astronomy, Betelgeuse might experience a supernova in the future. So basically it is nearing its death, basically. And then we have Rigel. Rigel is this one. Rigel is a very bright blue supergiant forming the Orion's left foot, and it is a young but is a massive star, burning fuel very quickly and will have a short life ending in a supernova. It is also gonna experience a supernova in the future. One day it is expected to experience a supernova. And then we have Scythe. Scythe is a hot blue star forming the Orion's right foot, like Rigel. It is a massive star and in an advanced stage, rapidly using its fuel, and it is really evolving towards a supernova phase also. But among these 3, the one that is actually nearing its death more is Betelgeuse. That's why you can see its color is more reddish. Betelgeuse's color is reddish. You can see it. So Betelgeuse is actually gonna likely to experience a supernova before these others. And then you have Bellatrix. We have Bellatrix. Bellatrix is a hot blue star forming Orion's left shoulder. It is a massive star in a later stage of its life, already evolving away from the main sequence after burning much of its hydrogen fuel. Bellatrix is this one here. This is Bellatrix. So these are the stars within the Orion constellation. And then you have heard about the Orion Nebula in natural science in grade 9. You learned about the Orion Nebula. The Orion Nebula is found in this region, as you can see there. That's where the Orion Nebula is. So anyway, this lesson is not about astronomy, but you can see that there's a connection between mathematics and stars. So anyway, let's get into it. We said the definition of a quadrilateral is that a quadrilateral is a closed shape consisting of 4 straight line segments, and the interior angles of a quadrilateral, they add up to what? 360. It means if I add this angle and this angle and this angle and this angle, I must get 360 degrees, right? And then the definition of a parallelogram. What is a parallelogram? A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So parallel, it means these are the opposite sides. AD is parallel to BC and AB is parallel to DC. So the opposite sides are parallel. So that's the definition of a quadrilateral, right? Yeah. So that's the definition of a quadrilateral. And then the interior angles of a quadrilateral, they must add up to 360. It means when we add angle A is this whole angle here. This is angle A, and plus angle B. This is angle B plus angle C. This is angle C plus angle D. This is angle D. When we add all of them, we must get 360 degrees. So this applies for quadrilaterals. So it applies for quadrilaterals. The properties of a parallelogram. Example 1. ABC is a parallelogram with AB is parallel to DC and AD is parallel to BC. So we are given that this is parallel to this and this is parallel to this. And then they say show that AB is equals to DC. So what must we do to show that AB is equals to DC? We're gonna use congruency. So we're gonna use congruency to do that. So to use congruency, we're gonna say in triangle ABC and triangle ADC, right? And then now we're gonna start naming sides or angles that are equal, right? So then we're gonna start. So we have what? We have what is equal here? We have AC is equals to AC. This is a common side. This is common. And then we also have what? We also have that this angle here is equals to this angle here. How do we know that? Because of we can see a Z shape and the lines are parallel. So because of the Z shape, it means angle A2 is equals to angle C3. Reason, alternate angles, and then this is because of AB is parallel to DC. And then the other thing that we see that is equal is what? We can see another Z. This is another Z here. So it means what? It means A1, angle A1 is equals to angle C4. Remember, the alternate angles are only equal if the lines are parallel. So don't forget that. So alternate angles, and then this is because of AD is parallel to BC. Then after doing all this, then we can make a conclusion and say, therefore, triangle ABC is congruent to triangle ADC, and then the reason will be what? The reason will be what? Angle, side. And then we can say, therefore, AB is equals to DC and AD equals to BC, and the reason will be congruent triangles. And this will be our reason. So then we just proved that. And then show that angle A is equals to angle C and angle B is equals to angle D. So now we want to show that angle A is equals to angle C and angle B is equals to angle D. Yeah, so now we are showing that angle A is equals to angle C. So we're gonna start by showing angle B is equals to angle D. So I claim that angle B is equals to angle D. And then what would be my reason? My reason will be what? Congruent triangles. We just proved that triangle ABC and triangle ADC are congruent. So yeah, so we'll use congruent triangles. So now we are done with angle B is equals to angle D. Now we have to show that angle A is equals to angle C. So how are we gonna do that? So the value of, we want to prove that the value of angle A is equals to the value of angle C. So we just proved that angle A1 is equals to C4, right? So we're gonna say angle A1 equals to C4, right? This one we proved it. A1 is equals to C4 is proved. And we also proved that angle A2 is equals to C3. A2 is equals to C3. This one is also proved. Then what we are gonna do, we're just gonna say angle A1 plus angle A2 is equals to, then where we see A1 we replace C4, and then we're gonna say C4 where we see A1, and where we see A2 we replace by C3, and then we have this situation. Now A1 plus A2 represents what? It represents the whole A. So this represents the whole A, and then this represents the whole angle C. So it means therefore we can conclude that angle A is equals to angle C. So we have proved what is required of us, right? Yeah, so this is because this angle represents what? It represents angle A, and this whole angle here, it represents angle C, all of it. Then we have proved that angle A equals to angle C, and angle B is equals to angle D. And then next it says, prove that if both pairs of opposite angles of a quadrilateral are equal, the quadrilateral is a parallelogram. Prove that if both pairs of opposite angles in a quadrilateral are equal, then the quadrilateral is a parallelogram. So let's begin to prove that this shape here is a parallelogram based on what we are given. So in order to prove that this is a parallelogram, we're going to use the concept of the co-interior angles. So we're going to use co-interior. So we know co-interior angles are supplementary if the lines are parallel, right? Co-interior angles are supplementary if the lines are parallel. The lines that form them are parallel, right? So this is what we're gonna do. We're gonna start with what we are given. What are we given? We are given that angle W is equals to angle Y is given, reason is given. And then we are told that angle X is equals to angle Z. It's given. Why is it given? Because both W and Y, they give us Y, and both X and Z, they give us what? A small letter X, right? And then next we're gonna say W plus Z plus Y, capital Y plus capital X is equals to 360. And then reason, we said that when we add four angles in a quadrilateral, we get what number? 360, an angle of 360. So the reason here will be sum of angles in a quadrilateral. And then angle W, angle Z, angle Y, and angle X. So angle W plus angle Z, then we're gonna replace this and this. Why do we replace? Because of, we just showed that W is equals to Y, and then X is equals to Z. So where we see W, where we see Y, we're gonna replace it with what? We're gonna replace it with W. Where we see X, we're gonna replace it with capital letter z. Then this is what then we have. When I say w plus z plus w plus z is equals to 360. And then after that, we're gonna then say w plus w is equals to 2w plus z is 2z equals to 360. And then what is the common factor here? The common factor is 2. And then we have w plus z is equals to 360. And then we're gonna divide both sides by 2. And then the 2's cancel, and then this side will be left with w plus z. 360 divided by 2 is what? Is 108. And then what does this tells us? It tells us that w here and then angle z here, these two angles, when we add them we get 180. So they are supplementary. Therefore we can make a conclusion that we can now make a conclusion that wx is parallel to zy. And then the reason being w and z are supplementary. So they are basically co-interiors. Therefore, we can make a conclusion. Therefore, what does that mean? Therefore, wxyz is a parallelogram. Because in order to prove that a shape is a parallelogram, we just need to prove that the opposite sides are parallel. In pairs. We just need to prove 2 pairs of opposite sides. So it must be 2 pairs. So why do we conclude? Because of you can also show the other 2 sides. So you can also show the other 2 sides. With other 2 sides am I referring to? You can also show that this side and this side, they are what? They are parallel. So we showed that this and this are parallel. Then similarly, you can show that wz is parallel to xy or yx. So yeah, this is how then we prove that the shape is a parallelogram. And then in this problem, we are given that PQRS is a parallelogram, PS is equals to OS, and QO is equals to QR. Angle SOR is equals to 96. Angle SOR. So angle SOR is this angle here. This is the angle SOR is equals to 96. Is this angle. Angle QOR OR is equals to x, is this angle right here. And then find with reasons two other angles equals to x. We are told that this is a parallelogram, right? So we want to find two other angles that are equal to x. So we are told that PS is equals to OS and QO is equals to QR. So QO is equals to QR, it means we have this situation. So therefore, QO is equals to QR is given. So therefore, it means triangle QOR is isosceles. Therefore, it means angle QOR is equals to angle QRO. Reason, base angles of isosceles triangle. Therefore, it means angle Q, it means we have x is equals to QRO. So therefore, this angle right here is also angle x. So we know that this is a parallelogram, right? And because it's a parallelogram, we can say that PQ is parallel to SR. Properties of a parallelogram. So we know that PQ is parallel to SR. Because PQ is parallel to SR, you can see a Z shape, right? This is the Z shape that I'm seeing. And because you can see a Z shape, it means this angle and this angle are equal. So it means another angle that is equals to x is angle SRO. So angle SRO is equals to angle QOR. Angle QOR. Reason will be alternate angles because of PQ is parallel to SR. Therefore, angle SRO is equals to angle QOR, and then angle QOR is x. Therefore, it means angle SRO is also x. So this angle here is also x. So there are three angles that are equals to x in this case. And then the next one says, the next question says write angle P in terms of x. So we want to write this angle right here, angle P, this angle right here, which is angle P. We want to write it in terms of x. So to write angle P in terms of x, again, this is a parallelogram. And then we know that angle P is equals to angle R. Reason, opposite angles of a parallelogram, they are equal. So therefore we know that angle P is equals to x plus x, which is P is equals to x plus x is angle R, so x plus x is equals to 2x. So angle P is equals to 2x. And then calculate the value of x. So now we want the value of x, right? Now we want to determine the value of x. So now the goal is to find the value of x. So to find the value of x, we're now gonna use this property that we are given, not the property but the hint. We are given a hint that PS is equals to OS. So this is the hint that we are given, right? So PS is equals to OS. And then we just showed that angle P is equals to 2x, right? What kind of triangle is PSO? PSO, because of PS is equals to OS, so PS is equals to OS is given. Therefore, it means what? Triangle. Therefore, triangle PSO is isosceles. Is an isosceles triangle. Because of is an isosceles triangle, it means this angle right here is also gonna be 2x, because the base angles of isosceles triangle are equal. So it means angle P is equals to angle what? Angle POS. So angle POS is equals to angle P. So reason here will be the base angles of isosceles triangle are equal. Therefore, it means angle POS is also 2x. And then after that, we can see that angle POS and angle SOR and angle QOR, they are all lying on the same straight line. And this is the straight line that they are lying on. So when we add all of them, they will give us 1/8. So then we're gonna say angle POS plus angle SOR plus angle SOR plus angle QOR plus angle QOR is equals to 180. Reason angles on a straight line. And then angle POS is 2x, so we're gonna replace here with 2x. And then angle SOR is 96 degrees plus angle QOR, and then angle QOR is x equals to 180. And then now we're gonna say 2x plus x, we get 3x. So you're gonna have 3x plus 96 is equals to 180. And then 3x is equals to 180 minus 96. 3x is equals to 180 minus 96 gives us what? It gives us 84 degrees, and then we divide both sides by 3, and then we get that x is equals to 28 degrees. And then that will be the value of x that they are looking for. And then next one, rectangles. Yeah, so rectangles, we have the definition of a rectangle. A rectangle is a parallelogram that has all 4 angles and equal to 90 degrees. And then we can see all the 4 angles, they are referring to the angles at the corners, right? So angle P equals to 90, angle Q equals to 90, and angle S is equals to 90, and then angle R is also equals to 90. So when you have a shape that has all these properties, that shape is a rectangle. And then a rectangle has all the properties of a parallelogram. Both pairs of opposite sides are parallel, both pairs of opposite sides are equal in length, both pairs of opposite angles are equal, both diagonals bisect each other. So bisect means divide into two equal parts. That's what bisect means. So example 3, the special property of a rectangle. So we have rectangle PQSR. So we are told that it's a rectangle. So PQSR is a rectangle. Prove that the diagonals are of equal length. So to show that the diagonals are of equal length, we know that we are given that it's a rectangle. If it's a rectangle, it means all the angles at the corners are what? Are 90 degrees. So and this is how we're gonna start to prove it. So we're gonna use a congruency to prove it, to prove that the diagonals are of equal length. Yeah, so using congruent triangles. So we're gonna use congruent triangles to prove that the diagonals are of equal length. So now I'm gonna make sure that I shade all the two triangles. So we're gonna deal with this triangle, and then let me use a different color to represent the other triangle we are dealing with, and we are gonna also deal with this triangle. Our goal is to prove that PR is equals to QS. So these are the diagonals. We need to prove that they are equal, right? So we're gonna use congruent triangles to do that. So then we're gonna start and say PS is equals to QR. So reason, opposite sides of rectangle are equal. And then next we're gonna say SQ is equals to SQ. Reason, common, the common side. It is the side, sorry, not SQ is equals to SQ. It's wrong. It's supposed to be, here it's supposed to be SR is equals to SR. The side that they share, that is common to both of them, is SR, the two triangles. The red triangle and the green triangle, they both share the common side SR. So, and then the reason is common there. And then we also have angle S is equals to angle R. They are both 90. So they are both 90. So because of here we are dealing with a right angle triangle, right? The longest side for triangle SQR is SQ, and the longest side for triangle SPR is what? Is PR. So it means then we have side, and then we have also SR is also a side, and then we have angle. So therefore we can say triangle PSR is congruent to triangle QSR. And then our reason will be angle will be side angle. Side angle. And then after doing all that, then what we can do now. So before we can do that, so we have side angle. So now we have proved that the two triangles are congruent. So therefore PR is equals to QS. Reason, congruent triangles. Because the triangles are congruent, then we can conclude that PR is going to be equal to SQ. Therefore, we can make a conclusion. Therefore, the diagonals are of equal length. The diagonals are of equal length. And then we have the summary of the properties of a rectangle here. Both pairs of opposite sides, they are parallel. Both pairs of opposite sides are of equal length. Both pairs of opposite angles are equal. Both diagonals bisect each other. Diagonals are equal in length. All interior angles are equal to 90 degrees. And then we have this problem here. So the problem says ABCD, problem 1. ABCD is a quadrilateral. Diagonals AC and BD intersect at T. AC equals to BD. So we are given that AC is equals to BD. So this is AC. AC, we are told that is equals to BD. And then AT is equals to TC. AT is equals to TC. So we are told that AT is equals to TC. And then we are told that DT is equals to TB. DT is equals to TB. Prove that ABCD is a parallelogram. Now we have to prove that this shape is a parallelogram, right? In order to prove that this shape is a parallelogram, all we need to do is to show that the opposite sides are parallel. If the pairs of opposite sides are parallel, then it's a parallelogram. So if we show that pairs of opposite sides are parallel, then it is a parallelogram. So to prove that this is a parallelogram, we're gonna prove that the pairs of triangles are congruent. So I'm gonna say that in triangle, I'm gonna say in triangle BTC and triangle ATD, and then we're gonna start. So we have BT. We have BT is equals to TD. So we have BT is equals to TD. It's given. And then we also have AT is equals to TC. AT is equals to TC is also given. AT is equals to TC is also given. And then we have angle AT ATD angle ATD, we have angle ATD is equals to angle BTC. These are vertically opposite angles. Therefore, we have a situation of side angle. Therefore, it means triangle BTC is congruent to triangle ATD. Reason, side angle. Then, therefore, we can say that angle TBC, angle TBC is equals to angle ADT, meaning TBC is this angle right here, and then ADT is this angle right here. So these angles are equal, and then the reason they are equal is because of congruent triangles. And then because they are equal, they form Z shape. Therefore, it means what? It means BC is parallel to AD. And similarly, we can show that AB is parallel to CD. Therefore, ABCD is a parallelogram. And then now we go to the second question. Says prove that ABCD is a rectangle. In order to prove that ABCD is a triangle, we need to prove that triangle. We need to prove that triangle ABD and triangle BCD are, no, not triangle BCD, that's my mistake. Triangle ACD. If we can prove that these two triangles that I have marked yellow, if we can prove that they are congruent, then we will be able to determine whether this is a rectangle or not. So we need to first prove that they are congruent, and already we have proved that the shape is a parallelogram, right? So we can say AB is equals to CD, opposite sides of parallelogram, they are equal. The opposite sides of a parallelogram are equal. And then the other thing that we can say it's equal, we can see that we have what? We have a common side. What is the common side that we have? We have a common side. The common side is O. AD is equals to AD. That's the common side. And then we were told that AC is equals to BD. This one was given. Therefore, we can make a conclusion that triangle ABD is congruent to triangle ACD. Therefore, it means that angle A is equals to angle D. because reason congruent triangles. Then after that, we can come here and then we know that this is a parallelogram, right? It means what? Angle A plus angle D are supplementary. Why? Because of they are co-interior angles. This is because of AB is parallel to CD. How do we know that AB is parallel to CD? Because we have proved that the shape is a parallelogram, right? Therefore, it means we can replace D by A, and then we have A plus A is equals to 180, and then A plus A is 2A is equals to 180, and then we divide both sides by 2, and then we get that A is equals to 90. And then if we do that, we will also find that D. We will also find that D is equals to 90, right? Therefore, we can conclude that the angles that are here are 90 degrees. We can also show that B and C are 90. Therefore, ABCD must be a rectangle. So ABCD must be a rectangle. So this is how we prove they're equal to 90 degrees, right? So, and then here we have a rhombus. The definition of a rhombus is that a rhombus is a parallelogram with all four sides of equal length. And then we can see here all the four sides are of equal length. A rhombus has all the properties of a parallelogram, and both pairs of opposite sides are parallel. Both pairs of opposite sides are equal in length. Both pairs of opposite angles are equal. It means this angle and this angle are equal, and this angle and this angle are equal. And both diagonals, they bisect each other, meaning they divide each other into two equal parts. It means you have this situation, TO is equals to OY, and then you have also XO is equals to OZ. Yeah. Then example 4, we said that bisect means what? Divide into two equal parts. So then example 4, special properties of a rhombus. We have XY ZT is a rhombus. Prove that XTZ Y. So prove that the diagonals bisect each other perpendicularly. Perpendicularly meaning they meet at 90 degrees. So here we need to prove that the diagonals, they bisect each other and they also meet at 90 degrees. So we need to prove that the diagonals bisect each other and they also meet at 90 degrees. So in order to do that, so we're gonna use the congruency method in this case. So we're gonna say, we're gonna use in triangle TXO and triangle ZOY. So we're gonna deal with triangle TXO and triangle, this triangle here is Y, ZOY. Then I'm gonna say TX is equals to ZY. This is given. And then after that, we're gonna say angle O1 is equals to angle O3, vertically opposite angles. And then after that, we're gonna say angle T2 is equals to angle Y1. Angle T2 is equals to angle Y1. The reason why they are equal is because of their alternate angles. So they are alternate angles because a rhombus is a parallelogram, right? So properties of rhomb. So we know that TX is parallel to ZY. And then therefore we have a situation of a side angle. Therefore we can say triangle TXO is congruent to triangle ZOY. And then reason will be angle side. And then after that we can then say TO is equals to OY and XO is equals to OZ. Reason? The reason being congruent triangles. And then after that we can then say that angle, and then we also see something. We see that TX is equals to TY. TX is equals to, no, TX is equals to XY. It's given. And then the other thing that we see is that triangle TXY is isosceles triangle. Therefore, it means angle T2 must equals to angle Y2. And then the reason is base angles of isosceles triangle. And then XO equals to XO. It's a common side. It's common. And then what we see again, then we can say triangle TXO is congruent to triangle XOY. Reason will be side angle side. So the reason will be side angle side. Therefore, we can say that angle O1 is equals to angle O2. Reason? Congruent triangles. Therefore, we can now come here. Let me use a different color. Therefore, we can now come here and say angle O1 plus angle O2 is equals to 180. Reason? Angles on straight line. But O1 is equals to O2. So we can replace O2 by O1. Equals to 180. O1 plus O1 is 2O1. You're gonna have 2O1 equals to 180. Then we divide by 2. Then angle O1 is equals to 90. And then we have proved. We have XO is equals to OZ. TO is equals to OY, and O1 is equals to 90. Then we have proved that the diagonals, they bisect each other perpendicularly at 90 degrees. So we have proved. So this is how we prove this whole thing. So let's move to the next. And then now we have to prove that the diagonals bisect the interior angles, right? So we have to prove that the diagonals bisect the interior angles. Now we just proved that TX triangle TXO is congruent to triangle XOY. We proved this, right? This one is proved. And we also proved that triangle TXO is congruent to triangle ZOY. This one is also proved. So this one is also proved. So therefore, we can say that angle X1 is equals to angle X2. Reason, triangle TXO is congruent to triangle XOY. So this will be the reason. So then we just showed that this angle and this angle are equal. And also we see something. We are given that XY is equals to YZ. It's given. So therefore triangle XYZ is isosceles triangle. Therefore angle X1 is equals to angle Z2. Then reason will be isosceles base angles of isosceles triangle. So it means angle X1 is equals to angle Z2, right? And then we see the same thing again. TX is equals to TZ. TX is equals to TZ is given. Therefore, we can say that angle X2 is equals to angle Z1. Again, isosceles triangle. It's an isosceles triangle, so that means this angle and that angle are equal. So then we have the same situation again. So because of we have proved that X1 is equals to X2 and X1 is equals to Z2 and X2 is equals to Z1. So therefore it means, diagonal XZ bisect angle X and angle Z. So now we have to show that diagonal TY bisects angle T and angle Y, right? So how are we gonna show that? So we're gonna first show that triangle TXO and triangle TOZ are congruent. So we can say TO equals to TO, that's common, right? And then we have TZ is equals to TX is given. And then we know that angle O1 is equals to angle O4. They are both 90. This is the properties of a what? of a rhombus. Therefore, we can then say that triangle TXO is congruent to triangle TOZ. And then because the triangles are congruent, and then the reason why they are congruent is side angle. Side angle, and then we can then make a conclusion that because now the two triangles are congruent, right? So we can make a conclusion that angle T1 is equals to angle T2. Reason, triangle TXO is congruent to triangle TOZ. And then now we know that T1 and T2 are equal, right? But we know that triangle TXY is isosceles triangle, right? Therefore, it means angle T. Why is it isosceles? It's isosceles because of Tx is equals to xy. Therefore, it means that angle T2 is equals to angle y2. And also again, triangle TZY is isosceles triangle because of what? Because TZ is equals to ZY. Therefore, we can make a conclusion that angle T1 is equals to angle Y1. Therefore, we can see that T1 is equals to T2 and Y1 is equals to Y2. So therefore, it means T1 is equals to T2 and Y1 equals to Y2. Therefore, we can say what? We can say that diagonal TY bisects angle T and angle Y. It divides them into two equal parts. So then this will be our conclusion. And then from this, then we are done with the solution. Then we can move to the next problem. Before we move to the next problem, then we just have to check few things. To prove a parallelogram is a rhombus, we need to show any one of the following: that all sides are of equal length, diagonals intersect at right angles, and that diagonals bisect the interior angles, like we have shown in this problem. And then now we have a square. A square, basically, it's a quadrilateral that has 4 sides that are equal, and the angles at the corners are 90 degrees. So that is a square. These are the properties of a square: 90 degrees, angles at the corners, and all 4 sides are equal in length. And then interior angles equal 90. So the definition of a square says a square is a rhombus with all 4 interior angles equals to all the four interior angles equals to 90 degrees, or a square is a rectangle with all four sides equal in length. So a square is a rhombus, so it's very important. A square is a rhombus with all four interior angles equal to 90 degrees. So the angles at the corners are equal to 90 degrees. Or a square is a rectangle with all four sides equal in length. A square has all the properties of a rhombus. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal in length. Both pairs of opposite sides both pairs of opposite angles are equal, and both diagonals bisect each other, meaning they divide each other into two equal parts. All sides are equal in length. The diagonals bisect each other at 90 degrees, meaning they meet at the right angle. The diagonals bisect both pairs of opposite angles, meaning they divide them into two equal parts. It also has the following properties: all the interior angles, they equal to 90 degrees, and then the diagonals are equal in length. Diagonals bisect both pairs of opposite interior angles, and they're all 45. So meaning the angles here, you have 45, 45, 45, 45, 45, 45, 45, 45, which makes sense. 45 plus 45 is 90, 45 plus 45 is 90, 45 plus 45 is 90, 45 plus 45 is 90. So you have that situation right there. To prove that a parallelogram is a square, we need to show either one of the following: that it is a rhombus, and that all four sides of equal length with interior angles equals to 90, or we can prove that it is a rectangle where the interior angles, they will equal to 90 degrees. So that's what we need to show in order to prove that a parallelogram is a square. So a square, so to prove that a parallelogram is a square, the first one says we need to show that it is a rhombus. So if we can show that it is a rhombus, meaning all the four sides are equal and the angles at the corners are 90 degrees, then it is a square. So a rhombus or we can show that we need to show that either one of the following. If we can show that it is a rectangle with interior angles that are equal to 90 degrees, then we will be able to show that it is what? It is a square. So if we have a situation where we know that the angles at the corners are 90, then if we can just show that it is a rectangle, then we can conclude that it is what? It is a square. And in order to show that it is a rectangle, we just need to show that the angles at the corners are what? Are 90 degrees. So if you have a quadrilateral that has four sides that are equal, if you show that it is a rectangle, then you can conclude that it is a square. A rectangle, meaning a rectangle with four equal sides is a square. Yeah. So this is the end of our lesson. We will meet next time. Bye for now.